Ladies and gentlemen, thank you very much for giving me a voice. Today I will talk about uh, a chapter taking account Baga's updates published and staged in 22 International Engineering Symposium and Engineering Application Industry and in Izmir Democracy University and was talk speeched in October 28 to 30 of 2022. Their work was taught by Professor Nuri Asba from Ege University in Turkey, and a title was taught by Evaluation of Environmental and Special Impacts of Biogas Industries. The discussion Green Deal, published by the European Union, shows that emission of greenhouse gas by 40% compared to by 2030 compared to the level of 1990 and increase the share of renewable energies in total energy consumption to 27%. This is very little, but renewable, environment pollution, and greenhouse effect and public were key findings in this research. Biogas is a key source of achieving these goals due to case that besides energy, it will give also many chemicals and many fertilizer in many subjects of life utilized in many ways. In the Professor Nuri was taking care mostly Turkey when he was representing today because I talked with Bengal University, and I will talk that Turkey imports about 70% of energy, especially from Russia, pipeline, and therefore we need that Turkey need some new sources of energy. So we place to be independent. At the same point, the safe and sustainable supply of energy has strategic importance for the biogas is seen as renewable energy source with the potential to contribute to the energy supply of Turkey and the world to ensure sustainable development. However, the impact of biogas plant of how the waste would be if are proper, the not unreacted are unconcerned because some biogas bottle slurry if has still some bacteria which if not from the proper environment of after proper treatment can have some pathogenic forms, but we need to sustain, find. Paying attention to water resources. Special planning is another issue to be considered in biogas plant. Paying attention to water resources, protected areas, spatial location planning will also reduce environmental pressure. The evaluation of waste of facilities and world-friendly energy, especially in digestive, can lower the carbon footprint of the facilities. Software tools such as life cycle analysis and a geographic information system contribute to planning with preliminary studies, allowing environmental pressures to be minimized. This covers the frame of life cycle analysis. Sustainable management are presented here by Professor Murray within the scope of the European Green Agreement and Sustainable Waste Management. Greenhouse effects and which are produced fossil fuels is the leading of unfortunate climate change increasing temperature and correct and irregular use of fuel force, which is still growing due to growing population, increase the rate of greenhouse effects and viscosity, especially carbon dioxide in global warming. The greenhouse gases effect is also calculated as carbon footprint. So how much per person exhausts carbon dioxide and how the more greenhouse effect is factor. Climate and climate change is one of the most important global problems today, and is the result of various activities of people. As it known, carbon dioxide is most crucial greenhouse effect gases, and share in total greenhouse effect is approximately 80%. Sustainability is concept to develop, protect the natural resources in the world while meeting the nutritional needs of people with the ever-increasing population. Energy needs to be also increased for the growing population. The limited available resources to meet the demand constitute one of the most relevant problems of sustainability and climate change. The use of renewable energy is the sustainable way for reduction of greenhouse effect. For these, new investments based on renewable energy sources should be made and supported as opposed to carbon-based energy systems. In particular, biogas energy is one of the renewable energy sources shouldn't be ignored when considering the biomass waste, degrading on the content of organic materials, anaerobic fermentation process, biogas and gas mixture containing 40 to 70% methane, 30% of carbon dioxide, and 0 to 3% hydrogen sulfide, and very little hydrogen in its structure. In addition to producing electricity, facilities significantly reduce organic waste that might harm the environment. Animal feces can contaminate underground and surface waters that lead for rapid spread of infectious disease. The use of animal manure need to be careful due to this infectious disease because animal manure also contain because are very good for biogas. But be careful, and careful can be very good soil fertilizer. Can be increased by waste produced and after processing biogas. The waste, however, are unable to generate enough heat when burned to generate heat. This waste provides effective energy production as well as waste recycling into soil because they may be treated by biogas facilities. Despite its many environmental contributions, biogas plant is also sustainability improvements in some processing forms, as drying, the numerous benefits offer, the optimizing biomass production necessary to reduce gas emission for reducing carbon footprint. Is the mainly focus on diverse feedstock, digestive management, and biogas end use. Although storage of digestate is regarded as a hotspot of greenhouse emissions, the digestate should be properly managed and disposed of. It might be used as biogas, biofertilizer, and agriculture, acting as a product or co-product as well as real chemistry source. The tools used for assess environmental effect and special location of biogas plant by Professor Nuri at management sharing decision-making stage. A system of biogas plant is proposed by Professor Nuri and life cycle assessment also. Life cycle is adapted. Which decision points are into consideration in site selection? Life cycle assessment is defined as the collection and evaluation of inputs, outputs, and possible environmental impacts through the life cycle of the product. In other words, life cycle assessment is a method used to evaluate the environmental impacts of byproduct or service during its lifestyle. Lifestyle cycle assessment has been standardized in ISO. The standard leaves methodological choices for selecting the functional unit, system boundaries, background processes, or environmental impact assessment methods. The primary goal of life cycle assessment of biogas energy system is to demonstrate how generating and using biogas as an energy source affects the environment. In the literature, life cycle analysis assessment studies have been carried out for a variety of goals, including contrasting feedstock, determining the best blend, updating emissions data, and contrasting various scenarios. Biogas plants assess agricultural products and make it possible to turn them into energy. However, biogas facilities can have an influence on the environment. Environmental impacts, greenhouse gas emissions, acidification, and eutrophication will be revealed during or after the operation of the facility are generally evaluated with the life cycle assessment. There are biological processes and energy conversion steps in a biogas system. Several life cycle analysis studies have only uh, focused on specific stages. It was seen that life cycle assessment studies on biogas mainly focuses on three subjects, as digested utilization, feedstock, and biogas utilization. The different parts of biogas plants have been subject of studies on life cycle analysis of biogas. It is possible to consider the primary goal of these studies as limiting the environmental impacts of biogas generation. The upgraded techniques are compared in biogas research. It has been research focused using biogas or upgrading to biomethane is more environmentally benign. It is highlighted that the carbon content of the electricity used in the upgrading process is the key factor for life cycle analysis. Marking also the methane loss at another crucial point of the environmental performance of biogas upgrading. Fertilizer using of digestate in life cycle analysis studies focus also on this focus could be good option to replace chemical fertilizer. For avoidance of energy and synthetic fertilizer resulted in the contribution of 3 kilograms per square meters of biogas production and proper agricultural spreading. This study has some similar gives similar comparison of using simple version midpoint technique and varied cycle, and our goal is functional is by 1 meter square of outlet biomethane. Only Professor Tian gave by using Gabi used 1 ton for of methane for generated for food scent. As goal of studies are comparing the environmental impacts of two woos for biomethane production, then was enhanced to and compared to electricity fuel buses, biodiesel, and fossil diesel. The other points are recognizing of hotspots inside the biogas system for optimizing this. The other comparison is significance of incineration and different anaerobic digestion configuration and how to make it that would be helpful for the process. The impact category is freshwater, global warming potential, stratospheric also depletion potential, photochemical oxidation for acidification, eutrophication, and human toxicity. In every activity, spatial effect, the activities for energy and production, this determines suitable sites for establishing of energy facilities of research of the technique. The geographic information system, a main tool for applying design, the system, which consists software, hardware, data, methods, and user, provides the opportunity to transfer and evaluate every geographically reference element that has meaning on Earth into an electronic environment. Geographic information system has started to be a method that is becoming widespread throughout the world during the installation phase of biogas plants. The biogas potential of the region is sum of farm animal manure and rural waste. This potential can be calculated using parameters such as livestock number or weight and methane production volume per kilogram of waste. There is compare of geographic space in different to mapping of poultry farms, which have poultry farms used in rural and urban states, as any worker that goes as defined by a blue line and owned by poultry sheds or public areas, method for regional bioenergy based on geographic spatial factors and dynamics yield simulation, used digital landscape model, and use crop distribution as fact land use, soil distribution and land cover, as well as other is component is by employing water nexus technology as biogas potential plants, new number of municipal wastewater treatment plants, and this is the most important in case of using agris. Also, settlement, rivers, love were conducted. Biogas plants are known to have many environmental impacts. For topographical feature, closeness to cities, the major roads, water resources, agriculture production regions, natural production areas, biological waste promotes economical transpiration and logistics, where all factors taken into account while choosing the best location for biogas plants. In order to find a suitable location for the installation of biogas plants, use GIS to analyze the parameters of the slope biomass availability in the area and intensity of biomass production. The calculation of and separation between urban residents and the residential areas, public roadways, water supply, and poultry farms and the feasibility of producing are examined, such as slope, settlement, river, topography, urban expansion, and important roads. Its potential permits high-resolution evaluation of geographic spatial data of the technical bioenergy potential at the regional level. In the frame of responsible production and consumption, which is one of the main goals, it is necessary to consider your experimental image, environmental, environmental and land use. In the study, Professor Nouri investigated in order to determine with reduced pressures on the environment in biogas production. He observed that life cycle analysis tools are useful for reducing environmental emissions, and geometric spatial tools can be used for land use decision. Life cycle analysis and geographic spatial impacts are convenient and accepted tools for location analysis and to measure the environmental pressure of biogas plants. These tools can be used by the Malagas University decision makers and environmental planners to set strategic roadmap to ensure sustainable. Thank you very much for listening.